Okay, so we're going to look at four-sided figures and circles. What we call those are cyclic quadrilaterals. So that's what the terminology says here. A cyclic quad, for short, is four corners are on the edge of a circle. Okay, so that's one way you can think of it. Corners are inscribed on the edge of a circle. Okay. So it's not just for any quadrilateral that you'll have these properties. It has to be one whose corners are on the edge of a circle. Okay. So we're going to take a look at using some of the properties we've already found and see if we can come up with the property that we've got here for cyclic quads. So from last day, can anybody find the left or the right question mark in this one? For this circle here. Sorry, maybe I didn't ask that. I didn't ask that. Can anyone find the left or the right question mark? This or this?
75?
The right is, there we go. See, I just didn't ask the question right. So the right is 75. And
105.
105. How did you get 105?
Because the middle point, it was 210.
So this is 105. Okay, let's try it over here. Okay, so this time, let's see here. Top and bottom. Can someone give me the top or the bottom?
Down there is 95.
Down there is 95. Actually,
That's my grammar stuff.
down there is not going to be on. Is not going to be 95.
Top is going to be 95.
Yeah, because the arc. This is the arc here. Okay, for this angle. So this is going to be the one that corresponds. So this one will be 95. Okay.
The bottom is 80.
Yeah, so the bottom is 85 because that means there's 170 here. So there'll be 85 in this corner. Okay, so not a bad little review of last day. Remember, they have to be on the same arc to work that way. Oh, sorry, did I do that backwards? Yeah, I totally did it backwards. That's okay. But you know what? For some reason, Jackie and I both swore we were right. So maybe my careless mistakes are starting to spill over to Jackie now. So Jackie, I apologize. I wouldn't want to ruin your career as a promising mathematician. So
Did that again.
did I do it again? Okay, hang on a second.
No, I was like, wait.
Okay, serenity now. Deep
95
breath.
down.
95 was the bottom. Okay, there we go, Ellis. I'll never not believe you again. Okay, how's that? And this was 85. Okay. So just to clarify, then, if it came from that arc, it was this angle here that would be using for this angle here. There we go. Okay. Don't fire me yet. We'll get through this. Let's see. Okay. So can you see a relationship then between the cyclic quads, which are these things, the four-sided figures, in these circles?
Add up to 180.
That is correct. Does anybody else, if I do it over here, I end up with, yeah. So here, 75 and 105 adds up to 180, and 95 and 85 add up to 180. Okay, so what we call this is we say that the angles opposite each other, we call that supplementary if they add up to 180. Okay, so angles opposite add to 180. Okay. Okay, now there's another property that we're going to find as well. So let's walk through this and see what we can get. Okay, so if I was to tell you that this angle is 95, can you find the question mark?
Yes.
Okay. Can you walk me through how to do that?
You can find the inside.
So the inside angle here,
Yep.
which is
85.
85. Okay, so then what's the opposite angle going to be? 95. Okay, so how did you get 95?
Up to 180.
It's got to add up to 180. Okay. How about over here? If this one is 100, what's this one over here?
80, the whole two angles.
Okay, the whole two angles, so these two would be 80. So what does that make the top corner? 100. Anyone see a relationship now?
The one that's down there to the right.
Good, that's a good way to describe it, outside the circle. We call these ones here exterior angles because they make their way outside of the circle. So those are what we called exterior angles. And we can see that these ones are equal. So for example, you get 100 and 100, 95 and 95. Well, if you think about the way you calculate it, you go 180 minus 95, gets me the first one here. And then you go this number, 180 minus this number, so it gets you back to where you started. So basically you're doing that 180 degree calculation, you're undoing it. So what's the relationship now? Well, the technical way that you're going to hear this said in your textbook, it says the exterior angle equals the interior opposite. So it's not that bad. If this is the exterior angle here, then this is the interior angle, outside, inside. So it's equal to the interior opposite. Okay, so that's the way you find it. You go from the exterior to the interior, and you go opposite. So the exterior angle is equal to the interior opposite angle. Cyclic quads. Okay, so here's a picture. You may want to include this in your notes just so that you're clear on how to do that. If this is the exterior angle here, then we go from exterior to interior and then opposite. So those angles are equal. Any questions so far on properties of cyclic quads? Good, because those are our only two that we're going to work with today. So let's practice using them. Hey, yeah. Okay, so I'm going to let you go ahead and start filling in the missing angles here using your properties of cyclic quad. Okay, let's let me catch up to you. So if this one's 63, then one thing I can get right away is this one must also be 63 in this corner. 78, this must add up to 180 with the opposite angle there. So that's going to be 102. And 63 and something has to add up to 180. So this angle here must be 117 degrees. Okay. So far so good? Okay. On this one here, it says this is 110, so this has got to be 70. And if this is an isosceles triangle, that means these angles have to be equal. So if those angles are equal, that means I've got 180 degrees in the triangle, take 70 away, divided by 2. That's 110 over 2. So each one of these angles has to add up to 55. Okay. Now, I believe this is missing a mark. There's a marker here. I think the mark is missing there. Possibly that's what you'd be stuck on. So if it's 230 degrees around this, that means there's going to be 115 degrees here. And these are the radius of a circle. So these are the same length. If that's 230 around there, then there's going to be 130 on that side to get me to 360.
It's H, so it should be 60.
Oh, I've done it again, haven't I? Okay. Yes, so now that I know this is 130, this one's going to be 65. And if there's 130 degrees, that means there's 50 degrees left in the triangle. So that means I'm going to have 25 degrees here and 25 degrees there. This angle that's right up here, I can find that angle by using the outside triangle. So there's this triangle that goes here, which has, oops, do I not have all the,
Yes.
oh I can, yeah, because I got 100 degrees here. So 25, that means this has to be the leftover amount to get me to 180. So there needs to be 55 degrees here. So 80 plus 100 is 180. So now I've got 80 degrees in the corner, plus 65 degrees, plus 25 degrees. This, and this. plus the missing one, which that looks like a J. I can't really tell. I think it's a J. Has to add up to 180. So that means I'm going to have 105, so 170 plus J has to add up to 180. So J should be 10 degrees. So 10 degrees. Okay, and then let's see here. Anybody have any luck finding I?
40?
40. How did you get this one here? How did you get 40?
I saw this triangle.
Okay, so if this is 100, there's 180, so each one must have 40 to add up to the 180. That gives me the triangle.